Hello, hello, hello. We are back with Chapter 10, Probability, Lesson 5, Making Predictions. Predictions, they are guesses about what will happen. All right? There are two methods of predicting, okay, that we're going to go over today. The first is using past evidence. Okay? So, for example, when playing darts, you hit the bullseye 5 times in 10 tries. Use this evidence to predict how many bullseyes you would hit in 50 tries. First, set up an equation relating the number of bullseyes hit to the number of tries. So we hit the number of bullseyes 5 times, and it was a total of 10 tries. So it's going to be 5 out of 10, okay? So this is using the past evidence of what we have already done. Since you know the number of future tries is going to be 50, you can use this proportion, okay? What we did, our past evidence, and then we're going to shoot it 50 times, and we don't know how many bullseyes we're going to get, so that's going to be X. But we're going to set up a proportion, and this is all based off of the past evidence of how we did. So we just go ahead and take our past evidence and what we're trying to do, and then what we don't know, we put an X there, and then we just solve it for X. So we just need to get X by itself. So X is we need to get it by itself on this side of the equation. Right now it's not by itself. It's being divided by 50. So we have to do the inverse operation of division, which would be multiplication. So we're going to multiply both sides of this equation by 50. Make that 50 over 1. It's 50 over 1. The 50s cancel each other out, and we end up with X. X is by itself. Now we just need to do this. Remember, whenever you're multiplying fractions, you look to cross cancel first. So we're looking here, is there anything we can cancel out? I would say there's a common factor of 10. 10 goes into 10 one time. 10 goes into 55 times. And there's nothing we can do there. So then we just multiply across. 5 times 5 is 25. Over 1 times 1 is 1, which means our answer is X equals 25. So we expect to make 25 bullseyes in 50 tries. Okay? So let's go on to problem 1 here. It says, how many bullseyes can you predict you will make in 70 tries? Well, we're going to take our previous evidence here of 5 out of 10, okay, and we're going to set that equal to, now we're going to go for 70. We're going to throw the dart 70 times, and we don't know how many, so we're going to use this past evidence to try to figure out what X is. So again, we need to go ahead and get X by itself. Right now it's being divided by 70, so we have to do the inverse operation to both sides, which would be multiplication of 70. 70 over 1, 70 over 1. The 70s cancel out each other out. We're left with X. Then we just need we're multiplying fractions, cross cancel first. So is there a common factor between 10 and 70? Yeah, 10. 10 goes into 10 one time. 10 goes into 70 7 times. And then we just multiply across. 7 times 5 is 35. Divided by 1 times 1, which is 1. So we end up with X equals 35, which means we would expect to make 75 bullseyes if we, we expect to make 35 bullseyes in 70 tries. Whew, that was more difficult than I thought. Okay, we are moving on to the second way. So predictions or guesses about what will happen. There's two methods. So the first method we just talked about was using past evidence, okay? Now this new way is creating an outcome tree. So we're rolling a number cube like this. And remember, how many sides are on a number cube? Well, here's a little diagram. There's 1, 2, 3, 4, 5, 6 sides on a number cube. So we are rolling a number cube, and you want to know how many times in 21 tries you can expect to roll a 1 or a 4. So we are trying to roll a 1 or a 4. Those are our desired outcomes. So in general, there are a total of 1, 2, 3, 4, 5, 6 outcomes on a cube. There's 6 sides to a cube. Of these, 2 of the outcomes, 1 and 4, are desirable. So we can say that the desirable outcomes, 2 over the total number of outcomes, which is 6, is equal to, and then we're going to roll it 21 times, and we want to know how many times, that's going to be our x, are we going to roll a 1 or a 4. So then we just use our algebra. We're trying to get x by itself once again. Right now, x is being divided by 21. So we need to do the inverse operation, which would be multiplication to both sides. These 21s cancel. We end up with x. And then we have to look to cross cancel here. So is there a common factor between 21 and 6? I would say yes, there is. It's 3. 3 goes into 21 7 times. 3 goes into 6 2 times. And then we're just going to multiply across. 7 times 2 is 14 over 1 times 2 is 2. And 14 divided by 2 is 7. So x equals 7, which means we expect to roll 7 1s or 4s in 21 rolls. Okay, so using this data up here, how many times can you expect to roll a 1 or 4 in 150 tries? So we're going to use the fact that with 1s and 4s, those are 2 favorable outcomes out of a total of 6 total. And we're going to have it for 150 tries this time. We want to know how many times are we going to roll a 1 or a 4. So we put an x there. And then we're just going to get x by itself once again. So right now, x is being related to 150 through a division. So we have to do the inverse operation of division, which would be multiplication of 150 to both sides. Those cancel. We're left with x. And I really think that 3 goes into both of these. 3 goes into 6 2 times. 3 goes into 150. I'm not sure. I'm going to have to do that division. 3 doesn't go into 1. It goes into 15 5 times. 5 times 3 is 15. I subtract 0. Got to drop it like it's hot. Drop that 0 like it's hot. 3 does not go into 0, so we put a 0 there, and boom, there we have it. 3 goes into 150 50 times. But I think I can cancel further because they're both even, 2 and 50. And so that means 2 goes into both of these. 2 goes into 2 1 time. 2 goes into 50 25 times. And then I think we're good. We just multiply across, which would be 25 times 2, which would be 50. So, yeah, x equals 50. So we can expect to roll a 1 or a 4 50 times in 150 tries. So let's go ahead and move on to some different examples. Example number 1 says, you throw a ball through a hoop once in 8 tries. How many balls can you predict you will throw through, how many balls can you predict you will throw through the hoop in 56 tries? We're missing the word through there. Okay, so let's take the information that we have. Okay, this would be the first one, using our past evidence. So we throw a ball through a hoop once in 8 tries. So that's going to be 1 out of 8. We're going to set that equal to, we want to know how many we'll throw through the hoop in 56 tries. So we're going to put 56 on the bottom and x on top. And then we're just going to go ahead and solve for x. We got to get x by itself. So we're going to use our wonderful, amazing algebra skills that we've acquired. This is x divided by 56, so we're going to go ahead and multiply both sides by 56. Okay, those 56 cancel. We look to cross cancel. Is there a common factor between 56 and 8? I would say yes, 8. 8 goes into 8 one time, and 8 goes into 56 7 times. And then we just multiply across. 7 times 1 is 7. 1 times 1 is 1. There we have it. We have x equals 7. So how many balls can you predict will be thrown through the hoop in 56 tries? We would say 7 balls through the hoop. in 56 tries. All right, there we go. Perfect, perfect. Okay, number 2. It says you flip a fair coin 16 times. How many times can you expect the coin to come up tails? Now we have a coin, so we're kind of using, we're going to create an outcome tree, okay? So with this coin, there's really 2 options. You have heads or you have tails, right? So there's heads or there's tails for the coin. Okay, so that means there's 2 outcomes here. But this right here is the desired outcome. We're trying to get tails. So that would be 1 out of 2 outcomes is favorable. So the favorable would be 1 tails out of a total of 2 outcomes. And so then we're going to flip it 16 times. We want to know how many tails we will get. So to solve that, we are just going to get x by itself once again. To do that, it's being divided by 16, so we have to do the inverse operation of division, which would be multiplication. We're going to multiply both sides by 16. Okay, those end up canceling. I kind of wrote that too close. We're going to look to cross cancel here. Is there anything common between 2 and 16? The answer is yes. 2 goes into 2 1 time. 2 goes into 16 8 times. And then we just multiply across. 8 times 1 is 8 over 1 times 1, which is 1. So we get x equals 8, which means we will have 8 tails in flipping a coin 16 times. All right, there we go. Okay, let's move on to problem 3. Now, problem 3 is a little different. They're going to go ahead and throw in a little percentage to us, but that's not a big deal. Okay, we can handle it. We can handle it. All right, you can do it. All right, thank you, Dragon. Okay, so you hit a ball 90% of the time. Predict how many times you will hit the ball in 200 tries. Okay, the cool thing about percentages is you can write a percentage as a fraction, right? 90% is the same thing as 90 over 100. So we're going to use this right here. So 90 over 100 is going to equal, well, we want to figure out, well, how many are we going to hit in 200 tries? And we don't know the thing on top, so we're going to put x there. That's how many times we would hit it in 200. And then we're just going to use our algebra skills to figure out what x is. So that's how you set it up. The biggest thing is how to set these problems up. Okay, so if you have a percentage, you turn that percentage into a fraction, and then that is your, this is your method 1 using past evidence. Okay, that's our past evidence right here. And then we want to use this evidence to predict what's going to happen in the future if we hit the ball 200. Or, you know what I mean? If we are throwing the ball 200 times, how many times do we hit it? So let's get x by itself. It's being divided by 200, so we need to multiply both sides by 200, which is the inverse operation of division. Okay, okay. We're cross-canceling. Those all become 1. We have x on this side, and then we have to cross-cancel over here. So what is common between, a common factor between 100 and 200? I would say 100 is. 100 goes into 100 1 time, and 100 goes into 200 2 times. And then after that, we can just multiply across. So I'm going to go off to the side. I'm going to go 90 times 2. 2 times 0, 0. 2 times 9 is 18. So we end up with 180 over 1 times 1, which is 1, which means it's 180 times. So we would have 180 hits with 200 tries. That's a lot of hits. That's pretty good. All right. So that's it for lesson 5. We will see you next time. Bye.